Database models. We distinguish 5. Hierarchical, networked, relational, object-oriented, and hybrids that consist of combinations of these 4. So hierarchical models are simply storing tables in a hierarchy. So the relations between the tables are a tree structure. And since it's a tree structure, we have parent-child relationships. So here on the slide we see an example. There's a university and it has a relationship to the table that contains data of the Faculty of Civil Engineering, and it has a relationship with the table that contains information of the Faculty of Computer Science. And the Faculty of Computer Science, again, there is a relation to people that work there and different departments in the faculty. So we see that we make a tree-like structure of the tables and the relationships. In a networked model, it's more or less the same, except that one table can have more than one parent, making it not a tree anymore, but a network. Here, for example, we see this table of people. These people can be at the Faculty of Computer Science, but they can also be at the Faculty of Civil Engineering. So we create this relation, and now we don't have a tree anymore, but we've got a network model where tables can have more than one parent. In relational database model, and this is the one we're going to look into more detail on later on also in the course, we have tables and we set up relations between these tables. That's why it's called the relational database model. So how do we set up these relations between these tables? We do this through a primary key and a foreign key. These are abbreviated very often with PK for the primary key and FK for the foreign key. So let's look here on the slide at the example. We've got a table that contains information about courses, and we have another table that contains information about students. So in the course table we've got a course ID, title and the amount of credits of a course, and in the student table we've got a student identification number, a name of the student and a course ID. So if we look at this specific example, we can say that the course ID is the primary key of the table course, because that's the column we use to uniquely identify courses. And courses are rows in the course table. So we need to make a relation between the courses and the students, because we need to make a relation of these students following the course. So we see in the student table there's also a column with course ID, and there it's called the foreign key, because it's that key in the student table that refers to the primary key of the course table that makes it possible to make a relation between these two tables. So that's how relational database works in a nutshell. Finally, we have object-oriented database models, and then data is just stored in objects. We've seen this in the module on object-oriented programming, where everything was an object, and an object had attributes for data and some methods on it. So in an object-oriented database model, this is basically what happens. Data is an object, and objects have attributes. So classes describe similar objects and they're organized in a hierarchy, as we've seen in object-oriented programming. So here we've seen the example we've already seen in that part of the vehicle. So we've got a vehicle, which is a superclass, and below it we've got subclasses that describe other types of objects. And below that, more concrete objects. So then the data in an object-oriented database is stored like a hierarchy of classes. And then finally, as I indicated, you can have hybrid models. You have, for example, models that are object relational database management systems, ORDBMS. Not going to go into details, but you can imagine that this is a hybrid solution where we have tables of objects and relations. In the next part, we're going to look more at structures of databases.